What's up, Sterile Processing Universe? It's Hank Balch here. We're back in studio with H20 Now You Know, and we got Christian Abell here with us. We're going to jump right in on this episode with a brief conversation about this biofilm word that we've heard out there. What does water have to do with any of that? And then we're going to talk about some stories of water quality challenges in the space that Christian has seen out there and his experience. And then here later on in some future episodes, we're going to talk about water quality testing and continue the conversation from there. But welcome back to the series, Christian. Good to have you back in the studio.
Thank you.
So biofilm, this is something that we learn in our initial onboarding orientation. We learn it in our certification textbooks that, hey, it's a bad thing. But what does biofilm have to do with water, or what does water quality have to do with maybe guarding against biofilm formation?
Well, you simply put, the exposure, let's give, I think an area that complicated geometry is a good place to kind of push your mind to even think about biofilms, how they can get into very deep crevices, into areas, obviously through instrument washers and mechanical actions, a lot of that gets removed. But where we're more concerned is this complex geometry, such as cutting blocks for total knees. Things that have really small spaces are hard to get into. You can't really brush them out. And the introduction of, how did it begin to start with, and it's not getting effectively cleaned. And once you have biofilms in a very preserved, safe place, safe haven, they get worse, and they can, tubing for like shavers, for arthroscopic surgery, that kind of stuff. It's very hard to get that stuff clean, and it's hard to see it. And if you have bacteria in your water or anything else, you're introducing it not only for the fact that it's being used on a patient, but you're also introducing it again through your process, in which case, depending on what the bacteria is, bad things can happen. And they get hard to track down. It's what I call chasing a ghost. And, it's not something that's easily seen. And then you go through a lot of random testing, and sometimes you can't reproduce it. And it just happens, and it goes away. And it's a very difficult challenge for the industry to be able to. It's not like we have tests that we can, necessarily monitor certain devices or high-risk devices that have the propensity for this type of thing to happen. And once it develops, it's hard to get out unless you know it's there.
Right. And even the idea that biofilm can form inside of our water treatment, pipes, tubing, equipment, etc. So it's not even just on the instrument itself that we're trying to reprocess, but the very equipment that we're relying on to help us to treat and to control our water could also succumb to this biofilm formation. So yeah, it's definitely a big threat, and it brings me back honestly to something that you said in one of the previous episodes. I think you were talking about potentially the silicates, or maybe another one of those chemistry words. But you mentioned you could rinse this thing for 10 hours and it's not going away, even with good high quality water. And the same thing is true in his biofilm kind of conversations, is you need more sometimes than just compliant water. You need to protect the device. You need to solve for those complex geometries, and then also keep it, once it's removed, keep it out of there. So,
yep. And, it's one of those things kind of tying in some of these other conversations that we had too, is even understanding your water systems and how it happens and how it begins. I see it seems to be a little bit maybe more of an incidence when people have, a deadheaded system where you're producing water that goes into a pipe and it just sits until it gets used. It's not recirculated back to a loop and through a UV light and repolished and maintained. And that's one of those design things that hopefully ST108 will bring to the light for a lot of people that have systems like that, or systems that have been around for a while that have dead legs in the wall. and you get that biofilm that just grows in that pipe that's been sitting there because they had sonics or something hooked up to it several years ago, and it's not being recirculated and treated. It just sits there, and then they identify, oh, we have bacteria or whatever in the system. We break it down, we clean it, and that same pipe that's sitting there doing nothing will start growing again. So, a good other, area that you can have this contamination you keep fighting, and you really never stop to look at the root cause of where it came from.
Yeah, that's a great takeaway, honestly, out of this video is, hey, go back to your facilities team, your plant engineering team, and say, hey, do y'all know, do we have any dead legs and any of our plumbing around here? Because I want to make sure that if it is, that we account for it, that we address it. So yeah, that's a great call out. So let's wrap this episode here talking about some stories, experiences that you've seen out there in the space around water quality. I know we referenced staining. That's something that we kind of see out there, but maybe kind of paint the picture from, hey, there's a problem out there. You heard about it. You came in, did your thing, and then what was the impact, or was the outcome of that?
Well, we could make this episode for days. Some of the stuff, it's interesting. I've had a lot of cases where I just, ran into situations of things I wanted to resolve. And I like the science, as you know, behind some of that. Like, for instance, gold handled instruments turn black. Probably have seen it out there. You take it back to Germany into the lab and never seen it before. It only happens in the US, and they kind of like look at us like, how did you even do this? So that was, something that I had to reverse engineer the process to figure it out, and using EDX machines in Germany, and some general ideas. I said, hey, take this out, blast it with radiation and a vacuum, and tell me if silver pops up. And sure enough, cool, silver popped up. I'm like, good, my theory's right. Now I just need to prove it. And then reverse plate, came up with, went and talked to some jewelers and learned how to reverse plate gold. Came up with a chemical reaction using, aluminum foil, boiling water, and baking soda. And I dropped the instruments in instantly gold, like brand new. I was like, sweet, it's like that kind of stuff where you can, and then it's like, okay, well, where's this plating happening? And you go back and you look at the water quality and the sonics, and you're like, that's where the bond is happening. The sonic is reverse plating the silver that's in the water onto the gold, oxidizing, turning black, and there you go. And they, you can chase yourself in circles, as again, chasing ghosts, thinking it's everything else under the sun, when it's actually not that complicated. You just have to kind of reverse everything. That kind of stuff, oxidation of different types of aluminum, trying to track that down. Carryover effects, I think, is a big one that I like looking at. It's like, well, you're doing X, Y, and Z in this part of the process is not wrong, but when you do this part of the process, X, Y, and Z then becomes Q. And that's where your problem lies. And often there's combinations of things that happen. And it's just that it's a matter of having all those experiences where you can go in and kind of really look at everything and come up with that type of solution. So I think, the 101s of my stories that I would say probably are the lion's share of them. It's just, having really good clean water, and they have corrosion, and understanding, and I'm sure we're going to probably get into that here at some point. In a diagram that I use for a lot of my lectures, is understanding the influences of corrosion, and a water being the center hub and all the effects of that. But it's really taking their stories, like, here's what you're doing, and hospital A and hospital B are doing the exact same thing with the exact same equipment, but both are getting different results, and why. And I run into that all the time. I do honestly run into that all the time, where everyone's comparing each other, apples to apples, so they think, and it's like, no, the behind the scene, you're completely different. What you're doing, how you're doing it. One softens their water and does this other treatment, and that influences, case carts that turn purple, or, rainbowed, or inside of washers that turn rainbow. And it's like, well, they're not having that problem. Why are we having a problem? So, diving into that science, understanding it, to me, it's a lot of, simple answers I can explain to them before even going on site. When you superheat a softened water and you have more available SiO2, it looks for some place to adhere, and boom, this is what happens. So,
I mean, that's a very important takeaway too. I think just practically on the networking side of sterile processing, especially in the digital age, if we share, hey, I was getting this kind of staining, this is what I did to fix it, and kind of giving this impression that, okay, that's the answer. If I get that same kind of stain, I know that I just need to do this and it's going to fix it. But what you're saying is that's probably not a good model of communicating best practices, because you're
right.
not dealing with the same plumbing system, equipment, water quality.
Yep. And I tell most customers, everyone does the same science experiment, and we all come out with different results.
Yeah. Well, I want to hear a little bit more about that silver experiment once we have some time. But we're going to wrap it for this episode. Christian, really appreciate your time. And I want to thank everybody else for tuning in, and tell you, hey, next episode, we're going to get into water testing itself. We've alluded to the different tests, but I really want to pick Christian's brain on what are these water tests? What does it look like? How do you do it? When do you do it? Et cetera, et cetera, et cetera. So hang here with us. Make sure to subscribe to the series if you're not already. And as we tell you all the time here at Beyond Clean, keep fighting dirty.